Next is Boolean algebra. So what is Boolean algebra? Boolean algebra is used to analyze and simplify the digital circuits. So Boolean algebra is used to analyze and simplify the digital circuits, or we can call it as logic circuits. So Boolean algebra is used to analyze and simplify the digital or the logic circuits. The Boolean algebra is always uses the binary numbers. It always uses the binary numbers, and those binary numbers are 0 and 1. So because of that, this Boolean algebra is also called as binary algebra. Boolean algebra is also called as binary algebra, or it is also called as logical algebra. Why it is called Boolean algebra or logical algebra? Because the Boolean algebra uses binary numbers, that is 0 and 1. So because of that, this Boolean algebra is also called as binary algebra or logical algebra. Now we will see Boolean laws. So first we will see the AND laws. In AND laws, we will see the first law. That first law is A dot 0 is always equal to 0. That means the ANDing with 0 will always results in 0 output. See here, A dot 0 is equal to 0. So ANDing with 0, we will get the 0 output, where this A is what? It is a variable here. Now see here how we can prove these Boolean laws. So see here, this is variable A. We have to consider two values here. Two binary values for this A. First we will take 0 here. So now see here, 0 ending with 0 is always equal to 0. Now we will take A. So A is equal to 1. Then 1 ending with 0 will always equal to 0. So if we take any value for this variable A, and if we ending with 0, then we will always get the 0 output here. Because of that, A dot 0 is equal to 0. Next, the second AND laws. The second AND law is A dot 1 is always equal to A. Now see here, A dot 1 is always equal to A. Now see, A is what? It is variable. So first we will take A is equal to 0. So 0 dot 1 is equal to 0, means 0 ending with 1 is equal to 0. So here at the output we are getting the value of A. Next we will check that with A is equal to 1. So 1 dot 1 is equal to 1 here. So here also we are getting at the output the value of A, so that we can write here A dot 1 is equal to A. See here again, we are checking with both the values. With both values, that is 0 and 1. We are putting A is equal to 0. then we are getting 0 output here, then we are putting a is equal to 1, then we are getting 1 output. So at the output we are getting the value of a that we are putting here in the input. Because of that, a dot 1 is equal to a. So this is the basic procedure to prove these Boolean laws. Next we will see the third AND law, and that third AND law is a dot a is equal to a. We are taking a as variable here, so a dot a is equal to a. Next, fourth AND law is a dot a bar. A dot a bar is equal to 0. Now see here, we are proving the third and fourth AND law here. First we are taking the third AND law, that is a dot a is equal to a. Now we are putting a is equal to 0 here, so 0 dot 0 is equal to 0. Next we are putting a is equal to 1, so 1 dot 1 is equal to 1. So at the output we are getting the value of a, value of variable a. Because of that, we will write here a dot a is equal to a. Next we will prove that a dot a bar is equal to 0. Now if we put a is equal to 0, then a bar is equal to 1. So 0 dot 1, that is a dot a bar, that is 0 dot 1 is equal to 0. Next, if we take a is equal to 1, then a bar is equal to 0. So here 1 dot 0 is equal to 0. So here the output in both these cases is equal to 0. Because of that, a dot a bar is equal to 0. So these are the AND laws in Boolean laws. Next we will see OR laws. Now the first OR law is a plus 0 is equal to a. That means the ORing with an input, ORing in an input with 0 will always results in the output that is equal to input. Now see here, a plus 0 is equal to a. Now if we put a is equal to 0, then 0 plus 0 is equal to 0. Now if we put a is equal to 1, then 1 plus 0 is equal to 1. So in the output we are getting the value of a. So because of that, a plus 0 is equal to a. Next, the second OR law is a plus 1 is equal to 1. So see here, a plus 1 is equal to 1. If we take a is equal to 0, then 0 plus 1 is equal to 1. And if we take a is equal to 1, then 1 plus 1 is equal to 1 here. So we are putting the values of 0 and 1 here in this second OR law, that is a plus 1 is equal to 1. And when we put a is equal to 0, then 0 plus 1 is equal to 1. When we put a is equal to 1 in this, then 1 plus 1 is equal to 1. So whatever the value of variable a, it is either 0 or 1, we will always get the output as 1 in this second OR law. Now the third OR law is a plus a. Third OR law is this a plus a is equal to a. Now see here, a plus a is equal to a. So if we take a is equal to 0, then 0 plus 0 is equal to 0, and if we take a is equal to 1, then 1 plus 1 is equal to 1. So at the output we are getting the value of a here. Because of that, a plus a is equal to a. So we can write here, or we can say that here, that ORing an input with itself, ORing an input with itself, that means a plus a here, ORing an input with itself result in the same output. So a plus a is equal to a. So ORing an input with itself, ORing an input with itself, we are results in the same output. So this is the third OR law. Next we will take the fourth OR law, that is a plus a bar is equal to 1. A plus a bar is equal to 1. Now see here, a plus a bar is equal to 1. So first we will take a is equal to 0, then a bar is equal to 1. So 0 plus 1 here. We are putting these values of a and a bar in this fourth OR law, that is a plus a bar is equal to 1. So here 0 plus 1 is equal to 1. Next we will take a is equal to 1. Then a bar is equal to 0. So 1 plus 0 is equal to 1. So a plus a bar is equal to 1. So ORing an input with its complement. ORing an input, that input is a here. So ORing an input with its complement always results in high output. That high output is 1 here. So these are the OR laws in Boolean laws. Next we will see the inversion law. Next we will see the inversion law, and this inversion law is a double bar is equal to a. A double bar is equal to a. That means this inversion law, it states that this inversion law states that the double inversion of a variable results in the original variable itself. This inversion law states that this double inversion, see this double bar here. So a double bar is equal to a. That means it states that the double inversion of variable, that is a here, results in the original variable itself. That means a, or a double bar of a, is always equal to a. So this is inversion law. Next we will see the commutative laws. The commutative laws. So first commutative law is a dot b. First commutative law is a dot b is equal to b dot a. So this is the first commutative law in Boolean laws, that is a dot b is equal to b dot a. The second commutative law is a plus b. Second commutative law is a plus b is equal to b plus a. This is second commutative law, that is a plus b is equal to b plus a. Next we will see the associative laws. The associative laws. So in associative laws, the first law is in bracket a dot b dot c is equal to a dot in bracket b dot c. This is the first associative law. Next, the second associative law, that is in bracket a plus b plus of c, a plus b plus of c is equal to a plus in bracket b plus c. So this is the second associative law, that is a plus b, that is in bracket a plus b plus c is equal to a plus in bracket b plus c. Next is the distributive law, and this distributive law, it can be written as a dot b plus c is equal to a dot b plus a dot c. So this is the distributive law, that is a dot in bracket b plus c is equal to a dot b plus a dot c. Now we will see the other important Boolean laws. So first other important Boolean law is a plus ab, a plus ab is equal to a. Now see here, we have to prove this. So first we will take here the left hand side, that is a plus ab. Now see here, if we take a common, then we will write here a in bracket 1 plus b. But according to OR laws in Boolean law, what is b plus 1 or 1 plus b? 1 plus b is equal to 1. So we can write here a dot 1 plus b is equal to 1. Now a dot 1 is equal to a according to AND law. So here the left hand side becomes equal to the right hand side here, and that right hand side in this equation, that is a here. So we can write here left hand side is equal to right hand side. So this is the proof of the first other important Boolean laws, that is a plus ab is equal to a. Next, the second important law is a dot in bracket a plus b is equal to a. Now see here, the right hand side, that is RHS, is equal to a. Now what is left hand side here? Left hand side is what? It is a in bracket a plus b. Now we can write here, according to distributive law, we can write this a dot a plus a dot b, but a dot a is equal to a according to AND law. So we can write here the left hand side is equal to a plus of ab. Now if we take a common here, then it will be 1 plus b here. Now we can write here a dot 1 plus b is equal to 1 according to OR law. We can write 1 plus b is equal to 1 here. So in bracket we will write here, we are using the OR law, that is 1 plus b is equal to 1. Now a dot 1 according to AND law, it is equal to a. So now the left hand side here is equal to the right hand side, that is RHS. So LHS is equal to RHS. So this is the proof of this second other important law, other important Boolean law, that is a in bracket a plus b is equal to a. Next we will see the third other important Boolean law, that is A plus A bar B. A plus A bar B is equal to A plus B. So see here, what is RHS? RHS, that is right hand side, is equal to A plus B. Now we will prove that the LHS, that is left hand side, is equal to the RHS. So what is LHS? It is A plus A bar B. Now we are substituting A is equal to A plus AB here. Then we can write the left hand side as A plus AB plus A bar B. Then we can write here A plus, we are taking B common here, then we will write in bracket A plus A bar. Now we can write here A plus B. What is A plus A bar? A plus A bar is equal to 1. So we will write here dot 1 in bracket. We will write, we are using A bar plus A, or A plus A bar is equal to 1 here. Now we can write here A plus, what is B dot 1? B dot 1, or B and 1, that is equal to B here. So this is the left hand side, and this left hand side is equal to right hand side, that is RHS. So A plus A bar B is equal to A plus B. Next, the fourth other important Boolean law is AB plus AB bar, means A dot B plus A dot B bar is equal to A. So see here, what is RHS? That is right hand side is equal to A. Next, LHS, that is left hand side, is equal to AB plus AB bar. Now we are taking A common here, so in bracket it is B plus B bar. Now we are knowing that the OR law, that is B plus B bar is equal to 1. So if we substitute that, then LHS is equal to A dot 1. So A dot 1, that is equal to A according to AND law. So here the LHS is equal to the RHS. So this is the fourth other important Boolean law, that is AB or A dot B plus A dot B bar is equal to A. So this is all about the Boolean laws.